So question number 20 says the top speed of a car whose engine is delivering 250,000 watts or kilowatts of power is 240 kilometers per hour. Calculate the value of the resistance force on a car when it's traveling at its top speed on a level road. So if this is our road and our car is here, and basically, we have we have a car with a nose, right? The forces acting would be our force of gravity. We would have our normal force. We'd have our engine pushing it forward, and then we'd have some form of resistance force pushing it back. Now, if it's at its top speed, what that means is that it's not going to be going any faster, so that would mean that we have a constant velocity, and that would tell me then that the net force is going to equal 0. So the force of gravity and my normal force would be the same, as well as the engine and my resistive force are also going to be the same. Not all four of them the same as each other, but my x values are the same and my y values would then be the same. So the first thing we need to do is just understand what is the resistive force. And so what I can say is that the force resistive is the same as the force of the engine. And so the power of the engine, is going to be the same as the power of the resistive force. So if I can understand what the power is of the engine, and with that I could find the force of the engine, I should then be able to figure out the same value for my resistive force. So power is force times velocity. The power that we have for this is 250 kilowatts or 250,000 watts. My velocity is going to be 240 kilometers per hour or 66.67 meters per second. So we need to make sure we have things converted into SI units, both watts and meters per second, to be able to use this appropriately. And then with this, it just becomes a very simple equation of power divided by my velocity equals my force, which is going to be 250,000 watts divided by 66.67 meters per second. And that's going to give me a force of 3,750 newtons. So that's how big of resistance I'm going to have, whether it's due to air or rolling resistance. That's going to be the size of the force that's acting backwards here. The engine is going to be applying an equal force forwards due to it traveling at a constant velocity.